a keynote for the day by David Gamba, Senior Director, Aerospace and Defense Vertical Marketing, Xilinx. Before I invite him on stage, a very brief introduction. David Gamba, like I mentioned, is Senior Director at Xilinx and leads the Aerospace and Defense Vertical Marketing team. David has spent 18 years in the FPGA industry and has been recognized by the industry for introducing hard floating point into FPGAs as well as the OpenCL programming language for FPGAs. Additionally, David has spent 5 years leading the sales and marketing organization for Aluros and assisting with sales and marketing activities for Hot Rail. Ladies and gentlemen, it is a privilege to have him here with us this morning. Please extend a warm welcome to David Gamba.
So thank you for coming out today. I'm really honored and humbled to see all of you in the audience today and to be part of this excitement that we're experiencing. Today I really want to talk about space. And one of the things I'm going to really focus on is the concept of intelligent electronics. And what better way to illustrate and talk about that than by celebrating the success of the Chandra 2 moon landing, right? This showed the world India's capability of being one of the foremost in technology, in space, and the ability to achieve what less than a handful of countries could achieve. Remarkable and very humbled to be part of this community. I'm also honored to be part of the Xilinx team that participated in this project. So we've had devices in the synthetic aperture radar which are going around and helping to monitor the poles for the different ice and water. In addition, we helped alleviate that 15 seconds of terror by having our devices involved in the lander module to really pick out a suitable area for the lander. Now, this is one of many projects that Xilinx has been involved with for space. And we have a rich heritage of supporting ISRO and the Indian community in space projects. And I'm very pleased that we're going to continue doing this. We are involved in multiple projects with ISRO. Many of them I cannot talk about here. I wish I could, but I can't. And we're going to continue to push our technology and introduce products and capabilities to make ISRO and the space community a tremendous success. Part of our non-ISRO heritage, non-India heritage, is shown here with our Vertex 5 surf devices, which are a radiation-hardened device that has been in production nearly a decade. It has heritage among over 100 missions. And we're able to offer devices that support synthetic aperture radar as well as altimeters, but also image processing, digital signal processing, communications. And one of the projects we're also very happy with is that we're on this OSIRIS-REx. So we helped land it on the asteroid and collect the samples and know those samples are coming back to Earth. So what we're seeing is actually the dawn of a new age. And this graphic here is showing that the traditional approach of government funding space projects, while it continues, does not stand in isolation in supporting the space exploration. We're actually seeing the commercial community start offering funding. We're showing here $18 billion that the commercial community is putting in addition to the government funding, to really drive space technology forward. Both the government activities and the commercial activities are going to benefit from this symbiotic relationship that they have. So this is what's very exciting. And what we're seeing is the dawn of what is called NewSpace. Some may call it Space 2.0, may call it commercial space, commercial constellations, but not in the traditional geosynchronous orbits, but in LEO and NewSpace orbits, we're seeing a tremendous amount of new entrants launching satellites. Companies we didn't hear of 10, even 5 years ago are now doing commercial launches. And they're being enabled by the foundation that ISRO and the space community and the rest of the world have put in place by making the technology available and then the efforts to increase the capabilities to reduce the launch costs, to reuse launchers, to really enable this new application space. And so some of the benefits that you're going to see is a lot more satellites out there. We're seeing it's a big race to be first, to really set up the constellations, the networks, the communications, and those are going to drive the cost down and increase the services and capabilities that we receive here on Earth. So this is a tremendous event. We're at a point in time that is unparalleled in history. So when I do a dichotomy of what we call the traditional space, and this is the government or the military programs, they're using space-grade devices, which really have to understand all the radiation and environmental effects for deep space. The volumes are not very high, and the mission durations are 10 to 15 years. This is actually in distinct contrast to what we see in NewSpace. What has been a surprise to me, and a surprise to many at Xilinx, the company, and even the semiconductor community as a whole, is these companies in NewSpace are taking commercial-grade devices and flying them. What they're doing is they're really accelerating this technology deployment. There's been a lot of questions about how they will be serviceable up there, how will they be successful. This is a big risk. But this is what makes it so fun. This is what makes it so exciting. This is why I say this is a moment in time for all of us, where we see the innovation in the forefront starting to really leverage commercial capabilities into these space applications. But I do say that both will coexist. I see a distinct dichotomy between the traditional space and the missions, new space and the missions, coexisting, but having that mutually beneficial, symbiotic relationship of driving technology, driving costs down, and enabling new capabilities that we never even dreamed of. So there's a lot of news about NewSpace. You know, SpaceX was mentioned earlier in the keynote, and they're launching a lot of satellites, and they expect to deploy those by late 2020. It is a race. They're moving very fast. Hot on their heels is Amazon as well. I don't know if many of you are familiar with the geography, but Amazon is very close to SpaceX. And actually, they swap employees back and forth. So they are in a very competitive race between the two companies to launch these constellations and get them up in service. In addition, Facebook, in partnership with Hughes, is launching a service as well to enable Wi-Fi hotspots in Colombia. And Virgin Galactic, Richard Branson's company, is looking to basically take passengers on the space flights. Now, I really enjoy stories like this, and in conjunction with working with our partners at Avnet and Spurg, DTDS, and Centrum, we're actually working with a lot of the Indian companies too, some startups in the NewSpace area. Unfortunately, due to NDA restrictions, I can't talk about what we're doing there, but I really hope to come back in 2 years and talk about similar successes like this with the India community as well. I look forward to that. But what's interesting is some of the names up there represent a few of the 2,000 plus billionaires we have in this world. And there's actually been a study that 5% of those 2,000 billionaires, either passively or actively, are involved in space. And so this is what's created a term for me called the battle of the billionaires. And so what they're doing is they're using their tremendous wealth to really drive innovation in the space community, whether it's to offer commercial flights up to space, like Richard Branson's trying to do with Virgin Galactic, or Jeff Bezos wants to go to the moon. And I think many of you know Elon Musk's goal, which I believe he will achieve, is he wants to get us to Mars and colonize Mars. This is why, again, I say this is a moment in time. The amount of innovation that has been driven in the space community, the amount of coverage that you're starting to get on TV, the periodicals. I mean, these launches are being broadcast live. We're watching these live. And there's so much interest that this has really been a reinvigoration of the interest level I see for space. So the trends we're seeing is you really want to do as much as you can up in space. You want to have those capabilities and not have to go back down to terrestrial mission control systems, stations, to implement the capabilities. So digital processing, you want to do the signal processing, you want to do the signal manipulation in orbit if you can. There's a lot of cameras and videos, equipment on these spacecraft. You want to do that imagery, the recognition, the manipulation up in space if you can. And a machine learning, this is ubiquitous now. Why not do it in space as well? So there's been a huge push to enable machine learning in space. And so I'm really happy to say that all these trends that programmable logic and Xilinx are playing a part in helping support and make these successful. For example, for machine learning in space, want to really do image recognition. You have very expensive cameras up there. The last thing you want to see coming back down to mission control station is a bunch of clouds. It's not a very good use of that satellite link. So we're showing a machine learning demo outside today at our booth. That same technology and capability can be used in space to identify things like cloud and make sure that this is not what gets sent back to mission control, but actually the images of interest are what gets transmitted back down. This is some of the key innovations that you're taking the terrestrial technology and making it applicable in space and really making a more successful and beneficial experience. The other thing that we're seeing is around communications is, again, you want to do more of the manipulation up in space. And when they're putting together all these constellations to drive communications networks, there has to be some way to do the manipulation and the processing in the satellite. And that's what our devices are being used for. This is showing a simple example of doing a regenerative transponder. We actually do reprioritization of the communications up in the satellite. You do not need to come down to the ground station to do that. Saves a lot of time, saves a lot of latency, saves a lot of cost. And this is what's making this available to the masses. So what is it about Xilinx and programmable logic that is so beneficial in space? You know, why are we being used so much in traditional space and new space? Well, the reason is in a space environment, it's very constrained. And so you want to have as small a footprint as possible up in space. In addition, it's very power constrained. So you want to do the best you can to remove as much power as you can from your system. So what I have here is a little bit of a history on programmable logic for FPGAs. So we start with a simple programmable logic device back in, say, 1990s. And we'd have all these external components around them, memory, SerDes, RF capabilities, vector processors, DSP. Those would all be external to our device. And then over time, we started integrating these capabilities. First, the block memory in the late 1990s. In the early 2000s, we started bringing in DSP capabilities, removing components from the board into a single device, lowering power, lowering the size. But why stop here? We kept on going. We integrated the SerDes in the mid-2000s. Then we started integrating a processor, application-based processor, integrated real-time processor, integrated gigasample per second RF capabilities in our latest generation of devices that are shipping in production. And I'll tell you, this device right now is in orbit with gigasample per second, DACs, and ADCs. The only company to be shipping this in programmable logic and monolithically today. Can't say who, but it's up there. The next step is going to be for vector processors. And the whole idea, you see, we're really taking that footprint and compressing it down into a very small, highly capable device, which by removing all those interfaces really helps drive the power down. The other aspect is these are standard products. So we help reduce the risk. You're not doing an ASIC tape out, for instance, and taking on all that risk yourself. You can buy these products today put the designs on them very quickly, keep changing the design all the way up to launch, and even after you launch and you're in orbit, do remote updates. And that is one of the key value proposition that Xilinx brings to the space community, is unlimited on-orbit reconfigurations. Now, in some cases, this is planned. We've seen customers who swap algorithms, swap waveforms after the device has been launched. In other cases, this is unplanned. And I often say that using programmable logic in space is the best insurance policy money can buy. Because we've had customers launch satellites, have an issue. One was around the area of a communication system. Identify the problem in the satellite. It wasn't our device, honest. But reconfigured our device remotely from mission control on Earth to work around the challenge and fix the communication link. This is how this on-orbit reconfiguration is a tremendous value proposition and really is going to help drive space community as well as things like machine learning, digital signal processing, that adaptability that you have a benefit of here on Earth in space as well. So one of our partner companies I could talk about publicly, Fraunhofer in Germany, is actually using this reconfigurability as part of their key element of their space application. They were launching a communication satellite, the Heinrich Hertz communication satellite. It'll be going up in 2021. It's for medical studies, and what they're going to be doing is occasionally changing the waveform and the payload application from space. And they're going to do that using our FPGA, and they're going to communicate up using the link that's going to go into the ADC, and they're going to update remotely the algorithm or the waveform as needed. What they will get from this is a tremendous use out of their satellites, and one satellite can be used in a lot of different applications. This flexibility, again, is driving new capabilities that heretofore have not been seen in the space community, but also that element of cost, really helping drive that cost down. And we talked about earlier today how cost can be very critical in these applications, right? There's not an unlimited supply of money. And this technology is really helping to drive costs way down. So Xilinx is very proud of our heritage. We're very honored to be part of the Chandrayaan-2 satellite mission. We're very honored to be part of other Israel and other missions as well. And we're going to continue investing with our space devices. Whether it's for traditional space, we're going to be introducing our next generation space device sampling end of this year. And I know there's a lot of demand for that. But we're also going to continue to introduce monolithic devices for use in space, whether it's the multiprocessor system on a chip or the RF system on a chip that's being used today. We'll continue to drive these roadmaps with our devices. We'll continue to support the radiation testing that is required, that is expected of us being a part of the space community. And we'll continue to support all the radiation test consortiums and our customer needs and making sure that they could use the Xilinx devices reliably with very high quality and take the full advantage of that key value proposition of the processing capabilities with that on-orbit reconfiguration to do things like the communication satellites, the machine learnings, the application swapping, and even the occasional bug fixes. So with that, I want to say thank you for inviting Xilinx. We're very proud to be a gold sponsor today. We're very pleased that the success that Israel and the space community is having here in India. When I travel to other countries, to be frank, they're asking me, how does India do it? And I really don't have the answer for that, but I will say that the prowess that many of you in this room and others who are not here with us today have raised the stature of India's space program tremendously, and it has been recognized throughout the world. Thank you.
Ladies and gentlemen, can we have a big round of applause once again for David Gamba for that keynote address. I'd like to request Anil Kumar from IESA to present a small token of our appreciation to David. David Gamba, ladies and gentlemen, Senior Director, Aerospace and Defense Vertical Marketing from Xilinx. I'd like to thank him once again for that keynote address.